Welcome to today's KickStart series for the course MRCOG Part 2, and the topic is Inferential Tests. Myself, Dr. Avinash SS, one of the mentor at Study Medic Study MRCOG group in the area of biostatistics and research methodology. In today's session, we will first begin with what are the tips and tricks to solve some of the problems that you may encounter in your examinations while appearing for the MRCOG and other courses. Initially, you need to give a very simple read on each topic. Choose a simple book and give a simple read on each topic. Solve questions from those particular topics. Identify the learning issues, what you are unable to understand or solve in each topic. Then understand and memorize those definitions, the concepts and formulas related to those topics. And when you encounter a question, analyze that question and translate the words in the question into a data which you can solve. Apply the related formulas and then solve the questions if needed. Go back, reflect what you did well, what you did not do well, and what you need to do if you encounter this question in future. How to prepare yourself and solve more questions. Now coming to tips and tricks to solve questions related to inferential tests. That is, you need to first understand all the assumptions that need to be met in order to use an inferential test. Read the question carefully. Check what is the hypothesis or the objective of the study or in that question. Check what are those variables that are present, whether there are independent variables, whether there are dependent variables. Check if these variables, whether they are continuous, whether they are categorical. And how many number of variables are there? Is it 1 or 2 or more than 2? If these variables are related, paired, or are they mutually exclusive? Check whether these variables, again, the question gives whether they are normal distributed or not. So if they all meet all the required assumptions, then go ahead and use the parametric type of tests. If they fail to meet certain assumptions or if they are not normally distributed, consider using an alternative, appropriate, non-parametric equivalent tests. Now, let us see diagrammatically what are those tricks and tips to solve questions related to inferential tests. Now, these inferential tests or the statistical tests are usually used to find whatever the effect that we are observing in our study, is it due to chance or not? That is what is given in the p-value after we do the tests. Now, in that particular study, you need to look at the type of the effect observed or the objective of the study and what is the hypothesis considered. And then see if all the assumptions are met, that is, if it is normal distributed, etc., for the selection of the tests. Then look at the type of the variables, if they contain, whether how many number of variables are there, whether these are continuous or categorical, if there is dependent or independent categorical variables are present, and if independent categorical variables are present, whether they are mutually exclusive or whether they are matched or paired. Also, look at the type of the distribution of these variables, whether it is normally distributed or not normally distributed. Then look at the other important assumptions. Then select, go ahead, the parametric test to be used if all the assumptions are met and if it is normally distributed, and equivalent non-parametric alternative tests to be selected if it is not normally distributed. And coming to examples, when do we use these tests? For example, if we want to find out the time of cesarean section, if there is a difference in time duration of the cesarean section conducted, right, between low risk pregnancy group and high risk pregnancy group. Now you can see that here the dependent variable is the continuous variable, and we are trying to find out the significance of the difference in mean of this continuous variable. You can see trying to find out the significance of the difference in mean of continuous variable between two mutually exclusive independent categorical groups. So low risk group and versus the high risk group. Between these two mutually independent exclusive categorical groups, we are trying to find out the significance of the difference in mean of the continuous variable, that is time duration of cesarean section. And if this time duration is normally distributed in both the groups, then the test that is used is independent t-test, also called as student t-test, also called as t-test, or unpaired t-test, all are same. Now if it is not normally distributed, then we can use the alternative to this independent t-test, and that is Mann-Whitney U-test. Now we will go ahead and see another example. Here we are trying to find out the significance of the difference in mean hemoglobin concentration between two groups before and after treatment groups. Now hemoglobin concentration is a continuous variable, and the independent categorical variables are, there are two independent categorical variables, but these are related groups, paired groups, matched groups. Hence, in such a case, when we want to find out a significance of a difference in mean of a continuous variable between two related matched or paired groups, that is not exclusive groups, and this continuous variable is normally distributed in both the groups, then the test that we consider using is the paired t-test. If it is not normally distributed, we can go ahead and use the alternative to this independent paired t-test, that is a non-parametric test, Wilcoxon sign rank test. Next, if we want to find out significance of the difference in mean hemoglobin, whether there is a variation in the mean of this hemoglobin between, you can see here, normal pregnancy, pre-eclamptic women and eclamptic women, and these are all mutually exclusive groups. These are all mutually exclusive groups. Here you can see there are more than two mutually exclusive categorical groups. Now here hemoglobin is a continuous variable, and there are more than two mutually exclusive categorical groups. Now hemoglobin, if it is normally distributed in all these groups, let us say, that is the assumption. Now if you want to find out the significance of if the continuous variable hemoglobin is significantly distributed, the mean hemoglobin, between more than two mutually exclusive groups, and it is normally distributed, we can use what is called as one-way analysis of variance, that is ANOVA. Now, if it is not normally distributed hemoglobin, then or other assumptions are not met, we can consider using the non-parametric equivalent, that is Kruskal-Wallis test. So Kruskal-Wallis test is the non-parametric equivalent to one-way analysis of variance. Now look at another example here. Here the type of operation, that is type of delivery, is one group, whether it is spontaneous vaginal delivery or LSCS. Now the women, whether they are normal pregnant women, whether these women are diabetic, and let us say whether these women are anemic, etc. This type of disease or risk present in women is another categorical group. So we have got two categorical groups here, right? And if we want to find out if there is an association between, type of delivery and if the woman is normal diabetic or anemic, or if the type of delivery is independent of whether the woman is normal diabetic or anemic. In both these cases, in other words, here we are trying to find out the association between two categorical groups. Here we are trying to find out a test of independence between two categorical groups, or if you want to find out if there is a difference in observed, that is the x and proportions and expected proportions of these categorical variables. In all these three instances, we can use chi-square test. So chi-square test is a test of association or a test of independence between two categorical variables. Now, when do we use Fisher's exact test? Both chi-square and Fisher exact test are non-parametric tests since they deal with categorical variables. Now, if you want to know more about Fisher exact test, do subscribe to our Study Medic Study MRCOG group. Coming to another example. Suppose we would like to know what happens to BMI as BP increases, whether BMI also increases. As BP decreases, BMI also decreases. If this is the question we want to find out. In other words, we want to find out, is there an association between BP and BMI or a relationship between BP and BMI? If at all, if it is there, is it positive or is it a negative association? What is its strength? That means if you want to find out the strength and direction of association between, you can see here BP and BMI both are continuous. So if we want to find out the strength and the direction of association between two continuous variables, and these continuous variables are normally distributed and linearly related, then we use the parametric test, that is the Pearson's correlation test, when the continuous variables are normally distributed and linearly related, and when we want to find out the strength and direction of the association. Here we do not presume any cause and effect relationship between BP and BMI. We merely just say they are associated. Now, for the further explanation of this, if you want, please do subscribe to our Study Medic group. Now, if one of these variables or both are not normally distributed, or if one of these variable is an ordinal variable, then we go ahead and use Spearman's correlation test, which is the non-parametric equivalent alternative to the Pearson's correlation test. That is the Spearman correlation test is what we use in that scenario. Now you can see below here there is a scatter plot between the BP and BMI. At a particular BP, what is the BMI? So scatter plot represents the association between the bivariate variables. Now here you can see one of the variable, that is the socio-economic status, is an ordinal variable, right? Whether socio-economic status is poor, middle class or rich. And if you want to find out the association between strength and direction of this association or relationship between BP and this socioeconomic status, which is an ordinal variable. In that instance, again, we can go ahead and use the Spearman correlation test. For further details, please do subscribe to our study MEDIC group. If you want to know more about what is this R value, what is this R value, that is the coefficient of correlation. How do you find out the strength of the association using this R value? What exactly this R value means? And how do you find out the direction of the association? To know further details, you do subscribe to our study MEDIC group. Another example we will see here, going ahead. Now, if you want to find out or predict GFR in ml per minute using creatinine value in milligrams per deciliter. Now GFR present here is a continuous variable. GFR is a continuous variable and creatinine is also continuous variable. Now you can say here GFR is dependent on creatinine. So it is given the value as Y. So Y is dependent on the independent predictor variable X. So creatinine here is an independent also variable, also called as a predictor variable. That means we want to predict the GFR, which is the dependent variable, from this independent predictor variable creatinine. Or if you want to quantify the effect of change in creatinine on change in GFR, or if you want to find out the effect of creatinine on GFR. So in these three instances, if you want to predict one dependent variable, if you want to predict one dependent variable from another independent variable, if you want to quantify the change in dependent variable from another independent variable, if you want to find out the effect of one independent variable on the dependent variable, in all these three cases, and if we are presuming a cause and effect relationship using a biological plausible explanation, then if this variable, dependent and independent variables, are normally distributed and linearly associated, we use what is called as regression test. Here in case we use simple linear regression analysis. That is, if you want to predict one continuous dependent variable from one independent predictor variable when they are normally distributed and linearly associated, we use simple linear regression. When we do this test, we also get what is called as an R square value, and which is called as the coefficient of determination. Now also we get an equation y is equal to ax plus b. To further know, to interpret this R square value, the p value and the other associations, that is a and b, please do subscribe to our study MEDIC group. So you can see in the scatter plot here, we get an equation which represents the mathematical correlation of the straight line between the dependent and independent variables. So another example we will see. Now, if you want to find out or predict the time of cesarean section, that is time duration of cesarean section taken when there is a change in hemoglobin concentration or if that person is obese or not. That means we want to find out the effect of these independent predictor variables, that is hemoglobin concentration and whether the person is obese or not, on the time duration taken for the cesarean delivery conducted on that person. So here you can see the dependent variable is again continuous time duration, that is continuous, whereas the independent variables, there are more than one independent variable here, right? You can see there are more than one independent variable, that is here is the hemoglobin and whether the person is obese or not. They may be continuous or categorical, it should not matter. In such a case, if you want to predict one dependent continuous variable from more than one independent predictor variables, whether continuous or categorical, then we go ahead and use the extension of this simple linear regression, that is multiple linear regression test. Again, here we will get an equation y is equal to a1 x1 plus a2 x2 plus b, and we also get an r square value. So how to further interpret these values, please do subscribe to our channel. Now coming to another example. Here we are trying to see what is this type of delivery, whether person undergoes cesarean section or spontaneous vaginal delivery. Now whether we can predict if the person undergoes cesarean section or spontaneous vaginal delivery on the type of presentation, normal or cephalic or breech or any other type of presentation, or whether the type of presentation affects the outcome of the delivery or type of the delivery present, or if we have to predict what type of delivery they might undergo based on the presentation when we are examination. In this case, you can see the type of delivery here is a categorical variable. Okay, the dependent variable. Type of delivery is the dependent variable, and here the dependent variable is categorical. The previous two examples of regression, the dependent variables were continuous. Here the dependent variable is categorical, and there is one or more continuous or categorical independent predictor variables. Here in this case there is only one. Then in such a case, if you want to predict a dependent categorical variable from independent variables, then we use what is called as logistic regression. Also in logistic regression, we again get y is equal to a into x plus etc plus b, and we get an r square value. Now how do you use this a values, association values, and how to find out odds of type of delivery using logistic regression when there is a different types of presentation, etc. Want to further know about these details, please do subscribe to our Study Medic channel. Now let us see whether we have understood these examples or not. Now here you wish to investigate the time it takes. To perform cesarean section on women with and without preeclampsia. So the time duration of cesarean section was normally distributed. Which test would you use to find the significance of difference in time duration of cesarean section between two groups? Here in this case, first we need to put this data into a table, either in mind or on a paper. We can put it quite like this. So this is the time of cesarean section in minutes, and these are the two groups. So you can see what would be the answer here. We are in a sense we are trying to find out the significance of difference in time of cesarean section between two mutually exclusive unrelated groups, that is preeclampsia and without preeclampsia group, whether there is a difference. And this is normally distributed. Time duration is normally distributed in the both the groups. Then in this case, the answer is yes, it is student T test. The alternative of the student T test is Mann-Whitney U test. Let us see. Let us see another example. Now, you wish to investigate the knowledge of women about cervical cancer, okay, about cervical cancer screening, their susceptibility, perceived seriousness of the screening, or perceived benefits. We are doing a survey here. But when we are doing it, before and after training them. So before also we take the knowledge score of this woman, screen this woman for the above parameters, and after training also we take these scores by collecting using the questionnaires. All the scores here, what they are given is normally distributed. Which test would you use? Again, when we write this, translate this into data and a table, this is what we can get. Example of the one variable is a knowledge score, which is a continuous variable. How it is different in women before the training, knowledge score is it different, and after the training. You can see the before and after groups. These are mutually not exclusive. They are paired groups. They are related groups. So here in this case, you are finding the significance of the difference in knowledge score between two paired groups, that is before and after treatment or training. In this case, and if they are normal distributed, what is the test we are going to use? Yes. If it is not normally distributed, we use Wilcoxon signed rank test. Now, if it was normally distributed in this instance, we would have gone ahead and used paired t-test. Now, another example. You wish to investigate knowledge about HPV vaccination against cervical cancer amongst women of reproductive age group. That is, there are, let us see how many groups are there. Less than 20 years, 20 to 40 years, more than 40 years. There are more than two categorical mutually exclusive groups. And here we are trying to find out the knowledge score about HPV vaccination. So if we translate this into data, the knowledge score in three independent categorical groups, mutually exclusive categorical groups. What is the difference in the knowledge score? In such a case, what is the assumption given? That it is not normally distributed. Now, if it was not normally distributed, what test you would use? Yes, it is Kruskal-Wallis test. Now, if it was normally distributed, which test would you use? Yes, it is ANOVA. So ANOVA we would use when the assumption it is if you want to find out the significance of the difference in means between more than two independent categorical groups, mutually exclusive, and if it is normal distributed. If you want to find out the significance of difference in continuous variable in more than two mutually exclusive categorical groups, and if it is not normal distributed and fails to meet assumptions, we use Kruskal-Wallis test, which is an alternative to ANOVA test. Again, we will see you wish to investigate if more obese women were associated with less physical activity. The sample size here is only 10. Which test would you use? Again, putting it into table, you can see we are trying to find out if the person is obese or not. Is it associated with physical activity? Now, if the person is obese or not, this is also a type of categorical variable. And if the person is doing which type of physical activity, this is also a categorical variable. So here in essence, we are trying to find out the association between two categorical variables, or if whether the person gets obesity or not, is it independent of whether the person is doing physical activity or not. So it's also a test of independence. Which test would you use? But here the idea hint is the sample size is only 10. Yes, we would use Fisher's exact test. Now, if the sample size was more than 20, let us say, we would have used chi-square test. To know more about, please do subscribe this. Now next, you wish to find if there is any association between weight and BMI in pregnant women. Weight and BMI were normally distributed. Let us see, weight is also a continuous variable. BMI is also a continuous variable. Both are normally distributed, and we are trying to find out if they are associated or related or not. We are also trying to find out the strength and direction of the association. Which test would you use? Yes, it is Pearson correlation test. If it was not normally distributed and some of the variables was ordinal, which test would you use? Spearman correlation test. Here you can see the coefficient of correlation was only 0.7. That means the direction is positive. As the BMI increases, weight also increases, and it is also a strong association. Now, another example. You wish to predict BP in preeclampsia women from their BMI. That means BP and BMI are normally distributed. So what are you trying to predict here? What is it? What is the objective here? Here you are trying to predict. What you are trying to predict? A continuous variable BP. Now, from BMI, another continuous independent predictor variable. That means we are predicting a continuous dependent predictor variable BP from another continuous single independent predictor variable BMI. And these are normally related, normally distributed, and linearly related. So which test are we going to use? Yes, right. It is simple linear regression. Let us see another example. You wish to quantify the change in BP. That means BP is the dependent variable in preeclamptic women from their BMI, physical activity, and socioeconomic status. So change in BP is the continuous dependent variable, whereas BMI, physical activity, and socioeconomic status are independent predictor variables. Now, which test would you use? The hint is it's an extension of simple linear regression. Yes, it is multiple regression analysis. So you can see, so we are trying to find out the predict the BP from BMI, activity, physical activity, and socioeconomic status. To further understand the meanings of this A1 value, A2 and other values, the R square value, etc., and the P value, how to interpret this regression, please do subscribe. Now, if you want to find out the effect of BP, let us say BP on neonatal outcome. So neonatal outcome here is a categorical dependent variable. So here we are trying to predict a categorical dependent variable neonatal outcome from any other variables, independent predictor variable. So when the dependent variable is categorical and if you want to predict or quantify or find out the effect on it from the independent predictor variables, we use logistic regression. Now to summarize, based on the objective, type of variable, type of numbers of categorical groups, etc., we will see one by one. How do we summarize? If the objective is, if significance of difference in means of a continuous variable between one group versus a population mean, known population mean, if it is normally distributed, we use one sample t-test. If it is not normally distributed, we use one sample Wilcoxon sign rank test, which I have not given the example here. Now, if you want to find out the significance of difference in means of a continuous variable between two unrelated mutually exclusive groups, we use student t-test. If it is not parametric, we use Mann-Whitney U-test, an alternative. If you want to find out significance of difference in means of a continuous variable between two related paired groups, we use pair t-test, and the non-parametric alternative is Wilcoxon sign rank test. Again, if you want to find out the significance of difference in means of a continuous variable more than two unrelated mutually exclusive group. This is an extension of student t-test. Here there are two mutually exclusive groups, and here there are more than two mutually exclusive unrelated groups. We use one-way analysis of variance. The non-parametric equivalent is Kruskal-Wallis test. Similarly, if you want to know more about how to find out the significance of difference in means of a continuous variable when more than two related groups are present, and with example when to use Aremanova test, please do subscribe to our channel. Next, based on the same criteria, if you want to find out the association or relationship, that is a test of independence between two continuous variables, we use Pearson correlation test, and an alternative is the non-parametric equivalent is Spearman correlation test. Again, if you want to find out association or relationship between two ordinal variables or one ordinal and another continuous variable, we use Spearman correlation test. If you want to find out association or relationship between two categorical, now coming to regression analysis. If you want to find out the effect of one independent continuous variable on a one dependent continuous variable, or if you want to predict this continuous variable from one independent variable, use simple linear regression. If you want to predict one continuous dependent variable from multiple continuous or categorical variables, use multiple linear regression. And if you want to predict one categorical variable, find out the effect of multiple or single independent predictor variables on one categorical variable, we use logistic regression. Of course, this is not as simple as we are making it out to be. There are a lot of other assumptions needs to be met before we use the parametric and non-parametric equivalent of the particular tests. Now, this is the summary. So, today we discussed what is the test to be selected, when do we select based on the objective, and what are parametric and non-parametric equivalent of this. Now you can see here, if you want to further know with several other questions that we can solve and further details of this, you need to subscribe to our channel. You can see we not only cater to MRCOG but also to MRCPI, MRCS, PLAB, NEET, and various other courses. As you can see, there are national and international courses. Also, we cater to 2-year clinical and non-clinical programs that are available in our group. Now, once you subscribe, you will be an exclusive member of so many groups that are formed, wherein a one-to-one with the mentors is available, sessions are available, those live session recordings are available to you. You have a free access to the library if you are subscribing, which contains audio podcasts, video preparatory videos, live session recordings, preparatory notes, mock tests, all based on topic wise. You can attempt it any number of times. Also, one-to-one discussions, intensive courses, etc. all are available in our group. Hope this session was KickStart series was useful for you. And if you are interested, please like, share, and subscribe. Thank you. All the best.